Myself, Nadaraj, currently I am working as an assistant professor in Electrical and Electronic Department in St. Martin Engineering College. Today we will discuss about the topic is transformer. Why we need transformer? What is the use of transformer? Why we call is the heart of the power system? Let me introduce what is the first briefly I explain about the structure of our power system. So why we call is the heart of the system. Now consider, because here consider this is your generating station. Now your generating station is far away from your load center. Consider this is your generating station at Ramagundam. It is the load center is Hyderabad. It is far away from your city. Now here it is a generating station. Now it will generating around, now India it is around 3.3 kV or 6.6 kV. Nowadays, new technology will be introduced, generate only 11 kV. Now these from 11 kV will be transferred to a load center. It is very difficult. We need some one medium will be required. Means we have to step up the voltage to reduce the losses. So that's the reason we can use of this your transformer. One transformer will be installed at our generating bus station. Now by using these transformer, we can step up the voltage from 6.6 kV or 11 kV step up to 440 kV. Nowadays we can using of the 765 kV also. Now by is up to okay. Now 440 kV is stepped up. So what is the use? Now we can using the transmission network. We can using this transmission network. By using this transmission network, we can deliver the power to your load center. Nowadays, transmission network, the double power system means you can using the double circuit line, quad line, and octa line. Now this is your transmission network. By using this transmission network, we can transfer power from generating station to load center. This is your load center. And also we have to install one more transformer. So why? Because why we need this one more transformer? So here this is the load center. Why we required? Means here transmitting what is the voltage here? 440 kV. This 440 kV cannot be used as our household or industrial application. Now we can step down to 440 kV into 220 kV. 220 kV again step down to 132 kV, again 33 kV and 11 kV. Now these 33 kV and 66 kV will be used for industrial purpose. Now these 11 kV will be used for household purpose. Now here we all observed some here in Hyderabad, then SPDC is there, Southern Power Distribution Company. This distribute our energy. Means the 11 kV will be transferred to our nearest homes. Then again this 11 kV will be stepped down to 433 volts. Why we require 430 volts? Because in the phase to phase voltage will be 433 and phase 2 line neutral is the 230 volts. Our all household appliances will be work on single phase loads only. So this reason we require 440 and 230 volts. So before why we call this is the heart of the system? Because there is no transformer, means transferring power from 11 kV generated power to the load center is around 270 kilometers. It is a very difficult. So that's the reason this transformer will be very important. So this is like a pumping, like a heart will be pumping entire blood circulation. So that's the reason we need transformer. Means this transformer means the transfer of energy from one circuit to another circuit by changing the voltage levels. By using this step up to 440 kV and step down to 11 kV. Okay, this is called step up transformer. This is called step up. This is called step up transformer. This is called step down transformer. So this is a very important phenomena in our electrical power system. Okay, now we introduce into our topic. Now, what is the topic means? What is a transformer? First, we have to consider what is the definition of transformer. Transformer is a static divide. It transfers energy from one circuit to another circuit without changing the frequency. Suppose here, what is the generating frequency here? Is 50 Hz. 50 Hz. What about our load center? What is the frequency? Here also 50 Hz. So just it will transfer power from one circuit to another circuit without changing the frequency. Suppose here Ramagundam is generating with 500 megawatts. Means this 500 megawatt will be transferred to from Ramagundam to load center. Means just using the step up voltage and step down the voltage without changing the these power voltages and frequency, it transferred to your load center. This covers the definition of transformer. Transformer is a static device. It transfers of energy from one circuit to another circuit without changing the frequency. And also some basic main features of the transformer. First we have discussed the features of your transformer. The main features. What is the features of transformer? So first one, transformer is a static device. Mean why we call static device? There is no rotating parts in our transformer like our machines. Machines having the rotating parts. Then the transformer does not have any rotating parts. That's the reason transformer is a static device. What are the features of the transformer? So first feature, what is the first feature? Is the constant frequency device. The first features of the transformer. The first one is the constant frequency device. Why we call constant frequency device? Because it is transfer of energy from one circuit to another circuit without changing the frequency. The second feature is the constant power device. It's a constant power device. Why we call constant power device? Here the generating power is, suppose example is the 500 megawatts. Means the amount of, what about the transfer of energy from 500 megawatts from generating station to load center without changing the power is called constant power device. And also transformer is the best example for the coupled circuit. What is a coupled circuit? Coupled circuit means the best example of coupled circuit. What is the meaning of coupled circuit? Means here transformer has this is your transformer core. This is your transformer core. So this is your core of your transformer. Here N1 is the number of turns. E1 is the induced EMF. N2 will be the number of turns. E2 will be the induced EMF. Now it is a coupled circuit means here these windings are means electrically isolated but magnetically coupled. That is called transformer is a best example for the coupled circuit. Transformer is the best example for your coupled circuit. And also we have to observe. So here only given single supply to your primary. There is no supply to your secondary. And also is a singly excited device. Transformer is a singly excited device. Transformer is singly excited device. Why called singly excited device? Means suppose what is the power supply we given? Only one supply is enough to energize your core of your winding. So there is no need of extra energy source in the secondary winding. So this is called is a singly excited device. The primary voltage V1, number of turns N1 and induced EMF is E1 and secondary is having the N2 number of turns, E2 will be the voltage. So this is the flux generated in your core of your transformer, the flux. And another example of transformer is, another feature of transformer is a negative feedback circuit. And another feature is called, it's provide the phasor displacement, means it is provide the 180 degree phasor displacement in the input and output voltages. What is the meaning? Suppose we are primary having starting from here. This is a 0 volt. Now your secondary will started from, means secondary voltages is starting from, is providing the exactly 180 degrees phasor displacement between the primary and secondary. Means that's the reason it's provide the 180 degrees phasor between the primary voltage and secondary voltage. What is the feature of transformer? First one is the constant frequency device, constant power device, and is the best example of coupled circuit. And what is the next feature? Is a singly excited device and is also provide the phasor displacement between the primary and secondary. Now, what is the use? How this is always possible? What is the working condition of your transformer? The working condition of transformer is based on Faraday's laws. We already studied even 12th class. What is the Faraday's law? What is the Faraday's law? Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction. By using this principle, transformer will work. Faraday's laws of electromagnetic induction. By using this principle, transformer will work. What is the principle of Faraday's law? Here means any revolving flux or stationary conductor, or stationary means moving conductor or constant flux, and EMF is induced in the conductor. Here is our, there is no revolving of conductors in our transformer. So what is the mean? Here is the only stationary conductors, means conductors are stationary. The flux is moving. This is a revolving flux. Then produces an EMF in the conductor. This EMF is called statically induced EMF. What is EMF called? Statically induced EMF. Statically induced EMF. And next EMF. The next EMF, what is the next condition? In this condition, conductors are stationary, the flux is moving. What is the flux is? The alternating flux is moving and cut the conductor, and EMF is induced in the conductor. The second point, second word means dynamically induced EMF. What is the dynamically induced EMF? What is the meaning of dynamically induced EMF? Means here the first condition, conductors are stationary. In the second conditions, the conductors are moving, the flux is constant. Then EMF is called dynamically induced EMF. Now in the transformer, we can consider only this statically induced EMF. The best example is the transformers. Statically induced EMF. Here is the motors. Okay. Now again, this statically induced EMF again into two types. One is the self-induced EMF and mutual induced EMF. Whereas the first one is the again statically induced into two types. Statically induced EMF or induced EMF, two types. One is the, what is called? Self-induced EMF. Second one is the mutual induced EMF. Mutual induced EMF. Okay. Now consider this is your pen. Now we can wind this pen with your wire. Okay. We can give the supply to this wire. Means what is the flux we give supply to this wire? Like consider this is a pen as your core. Core will wound with your copper wire. Suppose consider this one. Like this is your core. This is your core. Now these are number of turns. This is N1 is the number of turns. Now we can give in the supply V1 to your this turns. Now what is the Faraday's law? Means any relative motion. Here is the time varying current is flowing to your winding and produces a time varying flux. What is the meaning of flux? The flux will be equal to MMF divided by reluctance. What is the MMF? MMF is a magnetomotive force. What is the MMF? Means magnetomotive force. What is the MMF meaning is? Suppose here number of turns. Here number of turn is N1. Means number of turn into the current flowing in your this winding. This current is called I1. This is called MMF, means magnetomotive force. What is the reluctance? Reluctance same as like your resistors. So what is the resistor will do? It will oppose the flow of electrons. Same as reluctance will opposes the flow of flux in the core. So here, then what is it produced? Is the time varying flux will be produced in the conductor. The time varying flux will be produced in the conductor. This is called produced in the conductor. And what is the Faraday's law? A time varying flux will be cut the stationary conductor and EMF is induced in the conductor. This EMF is called self-induced EMF. Self. This is called self-induced EMF. Now, next one. What is self-induced EMF? Next one. Yeah. What is the Faraday's law? What is the Faraday's second law state? Means according to Faraday's second law, how to find this magnitude of induced EMF and direction of the induced EMF? By using this Faraday's second law. What is the Faraday's second law states? Faraday's second law. Faraday's second law. What is state? Here means according to Faraday's second law means what is according to Faraday's second law means any revolving means producing the EMF will be equal to rate of change of flux linkages. The self-induced EMF will be equal to induced EMF will be equal to rate of change of flux linkages. Rate of change of flux linkages. Rate of change of flux linkages. Here flux linkages will be number of turns into 5. So here what is the E self will be equal to what is the rate of change of flux linkages? N1 that into rate of change of flux linkages. Here dt by d5 by dt. What is the flux is time varying flux. So means the flux is varying with the time and EMF is induced. Why we need this negative sign here? Means this negative sign indicate the direction of the induced EMF. How to find the direction of induced EMF? By using Lenz law. By using Lenz law, you will give the direction of induced. Lenz law gives the direction of induced EMF. Lenz law will give the direction of induced EMF. Lenz law will give the direction of induced EMF. This is the self-induced EMF. Next, mutual induced EMF. So the name indicates the mutual induced EMF. Again, consider the core. This is your core. Now, then we have one with windings. Is the primary is the N1 number of turns. Secondary is the N2 number of turns. Now you can give in the supply to your primary. Yeah. Now mutual induced EMF. The name indicate mutual induced EMF. Now same. Again we can consider the core. Now this is your core of your single phase transformer. Now we are bound with N1 number of turns. This is the N1 number of turns and this is the N2 is the number of turns. Now we can give in the here supply will given to this winding means here is the time varying current is flowing to this winding. What is the flux? Flux will be equal to MMF by reluctance. What is MMF? Number of turns into current flowing in the winding. Now producing the flux in the core. Here this is the meaning of mutual induction. Suppose there is change in time varying current in the first coil and also there is a change of EMF in the second coil. This is called mutual induction of the transformer. This is called EMF, nothing but mutual inductions of the transformer. Transformer works on the principle of mutual induction. What is the transformer? Transformer works on the principle of mutual induction. So transformer works on the principle of mutual induction. Now this is the basic principle of the transformer. This works on the principle of mutual induction. Now next go into topic is what are the type. Now we are discussing the core. The core types. Here the basic have two cores. The cores will divide into a magnetic circuit. Depends upon your magnetic circuit, the core will be divided into two. One is the core type. Transformer. Another one is the shell type transformer. Here, what is the core type transformer? Here, now consider this core. This is a core type transformer. Consider this is your core type transformer. Then again giving the supply to your primary. Here the current will be I0. This is a N1 and this is a E1 and this is the number of turns will be N2 and this is your Load, when the load is connected, this called induced EMF is called E2. This is the core type transformer. The core type transformer here means the primary will give into your supply. Then what is the flux? Flux will be equal to MMF by reluctant. And EMF means an EMF is induced in your circuit due to of closed path. And also flux will be established in the core. Means this is the core type transformer. By seeing this here means the windings means the core means the windings are surrounded by core. By seeing this means the windings are surrounded by core and the mechanical production will be less for this core type and more for shell type. This is your shell type. This is a core of your shell type. This is called shell type. This is your shell type. One more. This is called, this vertical means this vertical is called limbs. It's called limbs. And this horizontal is called yoke. The horizontal is called yoke. Now consider to this part. Here is in the core type, how many limbs are there? 2 limbs are there for the core type. Coming to this shell type, how many limbs are there? Here we having the 3 limbs. 3 limbs. These are inner limb. These are inner limb. Both are. These are outer. These are outer limbs. So second one is there 3 limbs. One is a 2 limbs and is a 3 limbs. By seeing the figure means here is the means the core is surrounded by the windings. The windings surrounded by the core. So these are here is the mechanical strong. The mechanically weak. So this is the main difference. And also leakage flux. Here the leakage flux will be less. The leakage flux will be here. Core type will be the more leakage flux. Here is the leakage flux will be less. The leakage flux will be less. Means any leakages. Means like leakage flux is more means what about power transfer capability will be is less. The power transfer capability will be here is more. And what is the leakage flux? The differential leakage means the flux links with the only one winding is called leakage flux. That's the meaning. Suppose here the flux is linked with this only one limb. This is called leakage flux. Here means the leakage flux will be more in case of core type transformer. In case of shell type transformer, the leakage flux will be less and the power transfer capability will be, the core type will be less. Shell type will be more. And next one is the this is the main basic difference between the core type and shell type. What is the application? Next one, where we use this core type, where we use shell type. Here we use for low kVA application, this is used for shell type, and high kVA application we can use of the core type will be used as the low kVA and shell type will be used as the high kVA applications. Now next coming to the coming to the next point is the what is the use of, why we need this current. Well, next one is the no load current. Why we call it the no load current, why we require this no load current and how we will supply the hysteresis and eddy current related to this diagram. The meaning of hysteresis, suppose here it means hysteresis means suppose there is a alternating flux flowing in your core. Means this alternating flux flowing in a core means it will cut your core. This flux is cut your core. Means once the core is cut your flux means it will some produces an EMF due to of this closed circuit. An EMF is induced and also produces some current. This current is called circulating currents. These are very important. These are circulating current. This circulating current will flow into your transformer. This circulating current entire will flow into your transformer. This what is circulating current? What is the now causes losses in your transformer. This called eddy current losses. This called what is terminal is called eddy current losses. Eddy current losses. Okay. These are eddy current losses. Then how we remove this eddy current losses? Now means this is your transformer core. This transformer core is generally made up of silicon steel. So generally made of is a silicon steel. We can reducing the eddy current losses. Mean we can add 4% of silicon, 3% of silicon to steel. We add 4% of silicon to steel. Why we add means it is reducing the conductivity of your steel. We can reduce the conductivity of steel, we can reduce in the eddy current losses. Again, up to some further we can reduce the losses. Then again, this core can be again into using the lamination techniques. Simple, lamination is nothing but, suppose consider one white paper is like a silicon steel sheath. This sheath will be cut into smaller pieces. This means these cut into smaller pieces. The size will be dependent upon requirement. It's a 0.3 to 0.5 mm. These called and bunch it together to form your core. This called lamination. By using this technique, we can again reducing the conductivity of steel and reducing the eddy current losses. Again, we can reduce the eddy current losses. Then, we can reduce the eddy current. Next is the hysteresis. The hysteresis means we can using the varnish paint and also we can reduce the insulation, the conductivity of cover resistor. We can reduce the hysteresis loss also. Now, next we have to discuss about the phasor diagram under low load condition. Phasor diagram of transformer under no load condition. Phasor diagram of transformer. Phasor diagram of transformer under no load condition. Phasor diagram under no load condition. Before entering this topic, we have to derive some small equation of the induced EMF of the transformer. So, sir, what is the flux in the transformer? The flux will be equal to mmf by reluctance. The flux will be equal to mmf by reluctance. Now, what is the mmf? Number of turns into I mu. Yeah, this is a I mu. I mu. What is the mu? Nothing but is a magnetizing component of current. What is this I mu? It is used to set up flux in the core. This is called I mu sin omega t by r. Now, we will take as a I mu. What is the current will be taken as a maximum current IB will be equal to N1 into Im into sin of omega t by r. This is a flux. What is the value of flux will be equal to? Phi will be equal to N1 Im sin of omega t by r. Now, taken as this will taken as a phi of m. Now, the flux will be equal to phi m sin of omega t. Now, what is the Faraday's law? Faraday's law state means the rate means EMF will be induced according to the EMF induced the rate of change of flux linkages in the winding. What is the Faraday's law? What is the here? E1 will be the induced EMF in the winding. What is the Faraday's second law? Number of turns in the primary is N1. What is the flux? D by dt of phi of maximum flux that into sin of omega t. Now, this is the EMF E1 equal to minus of N1. What is the here? Derivative with theta. So, this is the phi m will be your now d by dt of sin of omega t. What is the derivative of sin theta? Is the cos of theta. Then omega of derivative omega. Then cos of omega t. Now, what is induced E1 will be equal to minus of N1 phi m omega cos of omega t. Now, we can write cos omega t in case of sine. What is the E1 will be equal to N1 phi m omega into sine of omega t minus 90. This means your induced EMF is lags exactly 90 degrees at omega t equal to pi. What happened? This is a maximum E1 will be induced means here induced will be max. This is your at omega t equal to pi. You can induce the maximum induced EMF in your conductor. So what is the E max will be equal to E1 max will be equal to N1 maximum flux that into omega. Now we always calculate in the electrical is a RMS value. What is the ERMS value? ERMS will be equal to E1 max by root 2. What is E1 max event? What is the value of E1? E1 N1 pi m and omega by root 2. What is the omega frequency? Angular frequency. N1 phi m, omega will be equal to 2 pi f, that by root 2. Then in calculating we will get the induced EMF in the primary winding is 4.44. Means next, what is the 4.44? Phi m, N1 and F. This is the induced EMF in your primary of your transformer. Same as your secondary of E2 will be equal to 4.44 phi m into and F. This is the induced EMF in transformer. Yeah. Now these are the topics of your transformer. Now all this the derivation will be completed. Now we can show the some animated video. So we can how the flux will be induced. What are the parts in your transformer? I will explain it through the video. Now this is your we'll explain through the video. This is a video. Now explain through the video. Now this is your transformer. These are distribution transformer. These called radiators. This is the breather. This is the Buchholz relay. Now this is your conservator tank. These are the parts of your transformer. Now so here means here what is the use of this? What is this called? Bushings. These are the bushings of your transformer. This is called bushings of your transformer. What is the bushings? What is the bushing? And this is called conservator tanks of the transformer. So means initially there is a empty space in your circuit. This is called bushings. Bushings of your transformer. These are HV bushing and LV bushings. Oh, what is the use of bushings? Suppose we have two windings. The primary is connected to supply, secondary is connected to load. Then how to these windings brought? By using these bushings, we can brought up the winding from the transformer. Means these are HV bushing means here the supply will given to through these bushings and the load will connected to your LV bushings. Normally these bushings are generally up to 33 kV we can use of porcelain type of bushings. More than 33 kV we can use of capacitor type or oil fill type will be used. This is the core of your transformer. This is your core of your transformer. Any observation? Means these cores are like this called concentric windings. What is the concentric winding? Means entire winding will be placed in your limb. This is called concentric winding. That means how this winding placed? First one is the LV winding is near to the core. The HV winding will give the outer part. Why LV winding is near to the core? Because here low voltage when required, less type of insulation. The HV winding belong to the after the means some distance between the insulation. Because the tappings. Here the secondary will be the tappings will be provided. Means the always tappings provided on HV side. Why we need tappings? So what is the use of tappings? Suppose in case of where what is the voltage in household is around 420 to 430 volts. Suppose the voltage will be less or will be more. By using this on-load tap changers, we can adjust the voltages. That's the reason the HV winding will be provided outside and LV is provided near to the core. We can reduce in the insulation of the core. Now next one. This is called breather. This is called breather. It is a breather. This is called breather. Why we need call this called breather? Why is called breathing? Nothing but so okay. Today is what is the topic we'll discuss? So types of construction, mutual induced EMF and mutual induced. What is the principle of your transformer? This is topic discussed today. Thank you.